Okay, let's continue our review with problem set number 5. We've got a plane traveling 500 miles an hour in the direction 150 degrees and encounters some wind in the direction of 45 degrees. I'm going to draw these in the coordinate plane. Here's your airplane traveling at 500 miles an hour. And we're going to just measure this direction here from 0, so 150 degrees. And then we've got a wind traveling that's at 45 degrees. And its speed is at 80 miles per hour. So the wind, smaller vector there at 80 miles an hour and 45 degrees. And then we have our plane that's flying at 150 degrees from 0 at 500 miles an hour. Well, to get the resultant speed and to get the direction, we're going to need to add these vectors together. So I've got 500 cosine 150 degrees, and then I have 500 sine 150 degrees. I'm going to add that to 80 cosine 45 degrees, and then 80 sine 45 degrees. So we have these vectors here. We're going to add those together. You type those into your calculator, and you get 500 cosine 150 degrees plus 80 cosine 45 degrees. That gives us negative, the next component of negative 376.444. And then in your calculator, when you type in 500, and then that's sine 150 degrees plus 80 sine 45 degrees, you get 306.569. So those are our x and y components. Now let's take them, square them, and sum them to get your speed. So we're going to take those components, we're going to square them, and then sum them together. I guess that one should be negative there. There we go. And we've got 306.569. We're going to square that. We're going to sum those together. And when you do that, you end up getting 485.484. And that will be in miles per hour. That's our ground speed. Okay, so that's the speed of this plane encountering this particular wind. In order to find the direction angle of the plane, we're going to take the inverse cosine, and we're going to divide our x value, negative 376, and we're going to divide that by the speed, 485.484. When you type that in, you'll to your calculator and take the inverse cosine of that fraction there, you will get a direction angle of 140.841 degrees. And depending on the problem, they may ask you to round to the nearest tenth or hundredth. So there's our direction angle, and there is our ground speed for this particular plane encountering this particular wind. So let's look at a few other problems. Problem set number 6. We have polar form, and we want to convert to rectangular form. So we have our magnitude, and then we have these angles and the cosine of that particular angle with our imaginary numbers. So we actually have these complex numbers written in polar form, and we want to convert them to rectangular form here. So what we're going to do is we're going to distribute that magnitude, if you will, the modulus, and that's going to give us our rectangular form. So we're going to get root 8 cosine 30 degrees plus root 8 sine 30 degrees, and obviously that's going to be times I. So root 8 times cosine 30, which is root 3 over 2, plus root 8 times sine of 30, which is 1/2, I. Well, root 8 can also be written as 2 root 2, so I'm going to write that as 2 root 2 times root 3 over 2. Well, these 2's will cancel. You'll end up getting root 2 times root 3. That's plus 2 root 2 times 1/2. These 2's cancel, and that's I. So the final answer here is root 6 plus root 2I. That's the rectangular form for this particular polar form here. Okay, same idea. We've got root 2 times the cosine of 135 degrees plus root 2 times sine 135 degrees. There we go. And that's I. Well, cosine 135, that's going to end up giving us root 2 times, let's see, that's negative root 2 over 2, plus, I believe the sine would be positive for this particular angle, so that's going to be root 2 times root 2 over 2I. Multiply the root 2's, you get root 4, so you have negative root 4 over 2 plus root 4 over 2I. Well, we know that the square root of 4 is 2, so that's negative 2 over 2 plus 2 over 2I, which is just negative 1 plus 1I. Okay, so there's our A plus BI, our rectangular form for those complex numbers, A and B there. So let's look at problem set number 7. Problem set 7 says write these complex numbers. They're in rectangular form at the moment. Write them in polar form. In order to do that, you need the magnitude and the direction angle. So let's find the magnitude, or the modulus here, of z. So again, thinking back to what we did with vectors, go ahead and square a and b, and then take the square root. So that's going to be 4 squared and 3 squared, or root 3 squared, so that's 16 times 3 plus 16. 16 times 3 gives us 48, plus 16 gives us 64. Square root of 64 is 8. Alright, then we also need to find our direction angle. So a simple way to find the direction angle would just be to take the inverse cosine of our A value here. You can almost think about it as an X value of 4 root 3 over 8. So take the inverse cosine of that really quickly in your calculator. So that would give us the inverse cosine of 4 root 3 divided by 8, and that's 30 degrees. Okay, so the inverse cosine of 4 root 3 divided by 8 would just be 30 degrees. So to write this in polar form, we would have 8 times cosine 30 degrees plus I sine 30 degrees. And in the interest of time, I want you to try to be on your own and check that with me, okay? So try to check that one with me in class. Let's go down to problem set number 8. So here we're just looking at some operations with rectangular and polar form. Here in rectangular form, sum is pretty simple. Sum your real values, sum your imaginary values, so you just get 3 plus 4 is 7, 6i minus 5i, that gives us plus 1i. Okay, 7 plus 1i. Here, I'm just going to kind of move from left to right. E, well, think back to polar form and why it's really nice when it comes to multiplication and division. Here I can divide these modulus values, or you can almost think of them as coefficients, and then I can subtract the angles. So 10 divided by 2 is 5, and then I have what? CIS 330 minus 135. So, in that moment, you may want to just grab a calculator and subtract those really quickly. Get 195 degrees. So 5 CIS 195. Polar form's really nice when it comes to division and multiplication. Subtraction, not so much. So here you're going to want to do 6 cosine 30 degrees minus 4 cosine 120 degrees. You almost have to break these two guys up, and that's your x component here, and then you're going to have sort of your y component, 6 sine, and I guess that would be I times this, sine 30 degrees, we'll put a plus sign in the middle here, minus 4 sine 120 degrees. Okay, 6 cosine 30, that's going to be 6 times root 3 over 2, minus 4 cosine of 120, which is going to be negative 1/2, plus I times 6 times sine 30, so that's 6 times 1/2, minus 4 times sine of 120, which is going to be what? Root 3 over 2, right? So 6 divided by 2, that's going to be 3 root 3, minus 4 times negative 1/2, so I guess that's plus 2, plus I times 3 minus, I suppose there you're going to have 2 root 3. Okay, so we have 3 root 3 plus 2 plus I times 3 minus 2 root 3. Just going to leave that guy right there. Here, I'm going to go ahead and say you could use your calculator for one, but a big concept that we've talked about in class is you can just multiply by the conjugate. Why don't you give that one a shot and check this one with me? We'll multiply by the conjugate on top and bottom. A nice thing that happens is you're going to get a squared plus b squared on the bottom, so that's going to end up being 9 plus 16, but then you're going to need to FOIL the top and see what you come up with there, and you're going to have a denominator of 25. So try that one, FOIL the top, see where it takes you. I'm going to try to quickly in the next few moments go over these last two. We'll go ahead and get rid of that there. Okay. Here, same concept. When you multiply in rectangular form, you could try to convert these to polar, but I would just say go ahead and use our FOIL technique. First, outer, inner, last. Probably going to be the fastest way going about this. So you get negative 28 minus, was that 96i plus 21i, and then that's going to be plus 72i squared. Well, we know I squared, that's like negative 1, right? So that ends up being a negative 72. Then you've got negative 96 plus 21, so that's going to be a negative 75i. And we've got this negative 28 here in the beginning. So negative 28 minus 72, so we've got, what, negative 100 minus 75i, once you've FOILed everything out. Here we've got something really nice going on, de Moivre's theorem. Look that one back up on Google, but you can basically raise your 2 to the 14th power, and then that's going to be times CIS 120 times 14. So in your calculator you can quickly multiply 120 times 14, and then essentially take 360 away from it to get an angle between 0 and 360. It doesn't take you long. You end up getting 240 degrees. So that would be 2 to the 14th power, pretty big number. 16,384. Cosine imaginary sine 240 degrees. There we go. And that's the end of our second review. If there's anything that still confuses you, see me in class. We'll go over it before the exam on Wednesday. Thank you so much.